Good morning to all. In this section of the fundamentals of building components, we see about the on the building components. We see now in this session we are going to see about the bearing capacity. So bearing capacity is the soil bearing capacity. It bears the full load of the building from in the foundation itself. So this depends on the soil, depends on the soil, which is depends on the soil and its moisture content and groundwater level content also. So in this one, the soil must be in the level itself such that it can able to withstand the pressure of the building, as well as if the soil is not the soil is not able to have the bearing capacity of the standards of the building, it may have a crack or the main structure can be able to failure. So this soil bearing capacity, we see about the foundation pressure as well as shear failure. So foundation pressure exerted by the foundation on the soil surface itself, whereas shear failure is soil failure due to the excessive shear stress itself, due to the excessive loading on the building itself. Also, you can see in the bearing capacity, the soft sand or gravel sand will have the high bearing capacity than the loose sand or silt sands. And also the types of bearing capacities are the ultimate bearing capacity or net ultimate bearing capacity, and net safe bearing capacity, gross safe bearing capacity, and net safe settlement pressure or net allowable pressure. These are the six types of the bearing capacity where we can able bearing capacity has been classified here. So the ultimate bearing capacity, the maximum pressure the pressure of the soil has to exert the pressure exerted from the soil has to withstand the foundation also. And in the fishbone diagram, we can see about the factors affecting the bearing capacity of the soil. First of all, the environmental conditions. So environmental conditions, there is a frost action, that is a dynamic motion, and the earthquakes. This is very rare, but also you must have some measurements on the earthquakes also. And next on the foundation characteristics. So foundation characteristics, the foundation, what is the depth of the foundation and what is the width of the foundation, whether it is a shallow foundation or else the deep foundation. And on this characteristics we must be based. Next one comes about the soil properties itself. So soil properties, the soil is a loose sand or gravel sand or is a muddy sand or clay sand also. Clay sand also have no bearing capacity itself. So you must go for the pile foundation itself in that. So it will be maybe the soil properties gives the collapsible and expansion soils as well as soil reinforcement. And next finally comes about these site conditions also. So subsurface voids or the seepage and soil erosion. And also the leveling of the soil also must be there. If it's in the hill stations, the leveling will not be as a surface of the flatness. It will be having some rocks will be there, so that you must have a proper way of soil foundation, soil bearing capacity also. And when you comparing this soil bearing capacity with variations, we see the cohesive soils and cohesive soils. Cohesive soils. Whereas the cohesive soil has unproportional increase itself, and cohesive soil will have linear variations itself. When we compare according to the cohesive soils, then we have to prepare the building also. Next one, the foundation of the effect of the soil bearing capacity on the strength itself, strength and the soil strength and foundation depth also. So strong soil we say is a loose sand or gravel sands will have a greater bearing capacity and deeper foundation will be there. Whereas weak soils, there is clay soils or slow silt soils will be having a declining bearing capacity. But for that one, you must have a shallow foundations. And next we see about the groundwater level also. So groundwater also plays an important role in the soil bearing capacity. So water table is impact on the bearing capacity itself. So high water table causes the uplift of the problems, and high water table on the causes on the congestion problems. Subsurface soil influenced by the water flow itself, and high water table also causes the steepage problems also. And surcharge of soil influenced by the water table itself. So on the having the foundation, you must see the water groundwater level must not be affect the foundation level, such that it will having a good bearing capacity also. So frost impacts soil capacity. It has the reduced capacity on the soil bearing weaknesses and also slip vulnerability. When it gives of the dry soil and moist soil, dry soil offers temporary stability but the prone to collapse it, whereas the moist soil causes structural shifts and long-term damage. In this we see, thank you. In this we have seen about the bearing capacity of the surface itself, which is the next part of the foundation. Thank you for watching it.